Okay, I have my spectrum analyzer here. What are we going to do today? Maybe I bought that 20 pack of Baofengs and I'm going to test them out, you think? No, actually, no. We're going to stick with the input connector to this spectrum analyzer. And today on Rhea Shack, I'm going to show you all about the N connector coming up. So to figure out the history of the N connector, you have to go all the way back to the 1940s when the United States military, who else, was looking to carry signals up to 1 gigahertz over a coaxial cable. The problem is none of these coaxial cable connectors were up to the task. Remember last week I showed you about the PL259 and its non-constant impedance. Well, this would have been a problem. Enter Bell Labs. Bell Labs, famous for developing technology and overcoming a lot of scientific challenges, developed a connector that had a constant impedance, was easy to put together, and as a bonus, it was weatherproof, and thus was born the N connector. The N connector is so named by its inventor, Paul Neal, a Neal with 2 L's, features a constant impedance up to 5,000 watts of power handling capability and frequency capability at that time up to 1 gigahertz. But actually that's not true. Modern N connectors can handle well above 1 gigahertz up to 11 gigahertz, and some later enhancements could have handled up to 18 gigahertz reliably. So the N connector is really no slouch. And to think that this little connector here, and I'll show you exactly what's inside of it here. You can slap this on a piece of coaxial cable, and then you can join them together, and then you don't even have to put waterproofing over them, and they'll be fine in the weather. Of course, I still put waterproofing anyway because I want to be doubly sure. But the secret sauce to that is, if you look in the front here, you will see a rubber gasket. And that rubber gasket helps keep the moisture out, because moisture is your enemy. In the back, and the way they come assembled is they have this rubber gasket in here. In the back, there is a, if I can find one, or I can just do this. You have to take this out here, and this little O-ring goes in the back of the connector, and it comes with a mating piece there, and this prevents water from entering in the back. Pretty clever little design. This is a clamp-on type N connector. This center pin is basically the center conductor. Your coax center conductor goes in here and soldered in this little hole, and that's how your N connector gets assembled. It bears a lot of resemblance to the BNC connector, and we all know the BNC. The BNC is used for small signals, and some people use it for transmit, some people use it for QRP radios. The BNC actually is a joint mishmash sort of between the inventor of the N connector, Paul Neal, and also another engineer by whose last name is, I hope I pronounce this right, Concealman. And he developed a Type C connector, not to be confused with USB Type C, but a C connector which had this bayonet on it. There was another engineer who brought the two together, and thus the BNC was born. A cool side effect of that is that you can actually take this N connector and you can put it on a BNC socket and it will make connection. So that is a brief history of the N connector. Why use N connectors? Coming up next. Why would you use an end connector? Why on earth would you use an end connector, especially considering the price? These things go, this one, the RFX one, I think this is an RFX one, goes for about $10 compared to a good quality Amphenol PL259, which goes for $3 to $5. If you have the regular non-RFX, which by the way I would use up on the tower, which I use up on the tower because I don't want to be climbing up there and I want my system as matched perfectly as possible, is about $20. Why would you do that? Well, there are a few reasons. One is the frequency handling capability. If you're using microwave, UHF microwave, you're pretty much stuck. I mean, you can use a PL259. You can probably get away with it up to like 70 centimeters, 450 megahertz. You could probably get away with a BNC connector for low power. But the end connector, you can do up to 5 kilowatts at 20 megahertz and 200 watts at 2.4 gigahertz, 2 gigahertz, no problem at all. So it makes it the perfect connector for UHF and microwave. And if you look at the cost of UHF and microwave gear anyway, it's still expensive. So the cost of connectors is really not going to add much to the cost of your station. The other reason I like it is the weatherproofing capability. Not only does it have this rubber seal in there, but it's very easy to put heat shrink on them. And I put heat shrink on the back of my connectors like this when they're made. Not only for weatherproofing, this is adhesive heat shrink that has adhesive in there. Not only for weatherproofing reasons, but also as a strain relief. I can't easily bend this, and this here is not going to bend and break. So a strain relief is very much welcome here. And you can't easily do that with a stock PL259. I mean, you can do it, but then the back and forth of the connector, it just doesn't work. This works fine. So those are all reasons I use the end connector. But as I mentioned a few videos ago, the real reason I use them is because I use hardline. And to be quite honest, the cost of the end connector for hardline was less than that of a PL259. So it did come down a cost. But they're readily available, and several flavors of them were available, and I just stocked up. I found them surplus. I found them from various sales and such. So I have a good few of them that I use whenever I run hardline, and they work really well. I have a few other places where I use end connectors. This is a Wi-Fi antenna given to me graciously by my friend Emmett Hohensi, and he he's a chief engineer at Radio Waves, really good guy. And this one uses an end connector, 2.4 gigahertz antenna / Wi-Fi, works really well. Test equipment uses it. This spectrum analyzer here, you can see, uses the end connector for the inputs. So I have my directional couplers and such going in there. And it has its uses. In Europe, a lot of the ham gear, I was told, the VHF and above ham gear actually comes with end connectors rather than PL259 for some reason. I don't know. Probably it's to comply with some European standard. Maybe I should ask one of these radio manufacturers what their reason is. But yeah, that seems to be kind of odd that they would offer it there and not here. So that is where you'd use them. Next is the part where I know you've all been waiting for, where we assemble one. And you know what? It's going to be pretty easy compared to the PL259. Coming up next. First things first, make sure you have the rubber gasket, washer, and the back nut on. Then you trim off about 8 millimeters of the outer jacket. you can take it back a little bit, flare it out a little bit, and then you proceed to take off about 4.5 millimeters or 0.177 inches of the center foam dielectric. Be careful to not nick the braid or the center conductor. It's especially important at UHF and microwave frequencies. So you just got to be extra careful. Again, there is probably a coax. I'm pretty sure there is a coax prep tool for this, but I don't have one. So I'm just going to use my knife. So next step is we have this little ferrule there. We have to also straighten back out the braid, and then we have to take extra care to make sure nothing's shorted. We put this little ferrule on and we put it in there, and then we fan back the braid, the outer shield. Make sure that it does not have any little strands shorting with the center conductor, and you try to make it as evenly distributed around as possible, as far as humanly possible, as I'm doing here. And make sure it's tight against the ferrule. Next up, we have the center pin, and we take the center pin and we gently put it on, taking care that no strands of the center conductor are sticking out. And to do this, we turn it and twist it and make sure it goes freely on, not twist it too hard so as to untwist the braids, but make sure it goes straight on. And you see that hole? That hole is where your solder is going to go, so we're going to solder it next. Okay, so we are here ready to solder the center pin. I turn on my Edson 951SX soldering station. I lower the temperature a little bit. I don't want it to get too hot on the center braid, and then as you see, it's almost nice and ready to go. The cool thing about this clamp and connector is that you don't have to have a lot of heat. You don't have to have a fancy soldering iron or a soldering gun, as several commenters have suggested. Make sure the solder goes in the hole. You don't want it to spill out too much, because that, one, could cause problems at UHF and microwave frequencies if you have any little spikes there, and two, it might cause it not to fit in the hole. Very easy. You don't need a lot of time. You don't need a lot of solder. Okay, the final step is to assemble the outer shell to the connector, and I must stress that you should use wrenches. I didn't have any wrenches here. I'm going to wrench this afterward, but you try to turn the back nut. Try not to turn the center body. This way you don't have stress on the center pin. But you turn the back nut and you use 2 wrenches and get it nice and secure. And there you go. That is your end connector. Alright, that's it for this week. Thank you very much for watching. And if you do like these videos, please give it a like and a subscribe. And look out for more videos. Next week we're going to be doing another set of connectors. But I think we covered the 2 major types here, the PL259EN. And there are other smaller types like the BNC and F connectors too. Believe it or not, F connectors are used on ham radio. Anyway, thank you, and as always, keep on hamming. Thanks for watching. 73.